The best way to approach this problem is to first have a better understanding of the standard deviation. So the standard deviation is the spread or the dispersion of a set of numbers about its mean. Or even more simply put, it is how far the numbers are from the set's average. So we're presented with set Y that contains the elements 2, 4, 8, and 6. And I'm actually going to rewrite this set so that it is in order with 2, 4, 6, and 8. And one of the things that we notice is if we were to add 1 to this entire set to produce a set that was 3, 5, 7, and 8, that even though the mean changes, this will still have the same standard deviation as its original set. And in fact, if you add or subtract any integer to a set, it will still have the same standard deviation even though it has a new mean. And we're going to use this logic to break apart the question. So I'm going to rewrite set Y below, and I'll keep it in the order that I just presented it in. So 2, 4, 6, and 8. And if we notice, the 3 sets presented in the answer options, they are all the exact same as set Y with different integers added or subtracted. Therefore, even though they have different means, they should still have the same standard deviations. And I'm just going to draw that out briefly to solidify that fact. So for set 1, we have 22, 24, 26, and 28. And all we did to go from Y to set 1 was add 20. Therefore, even though the mean is different and the numbers in the set are different, they will still contain the same standard deviation. Moving on to set 2, we have the numbers in the set that are -4, -6, -8, and -10. And all we did to get from set Y to set 2 was subtract 12 from each number in the original element. Therefore, similar to set 1, we should have the exact same standard deviation even though our mean is different, and it doesn't matter that they are negative numbers either. Now moving on to set 3, the final set, we have the elements in the set that are 0, 2, 4, and 6. And all we did to move from set Y to set 3 was subtract 2 from each element in set Y. Therefore, even though the mean changes once again, the standard deviation will be the same. So going back to the original question, which of the following sets has a smaller standard deviation than set Y? We know that set 1, set 2, and set 3 all have the exact same standard deviation as set Y. Therefore, this allows us to eliminate answer option A, B, C, and D, which leads us to the correct answer, which is that none of the sets have a smaller standard deviation than set Y because they have the same standard deviation.